Hi class, today we're looking at Chapter 6, Lesson 3, Multiplying with Scientific Notation. So astronomers use scientific notation when they work with very large numbers. To calculate using scientific notation, you must know how to multiply with exponents. The rule for multiplying powers with the same base applies to the multiplying numbers in scientific notation. So our first example here, 5 times 10 to the 6th power times 9 times 10 to the 3rd power. So we're going to start out by using the associative and commutative properties. So to do that, that means we can multiply these like terms together. So it's going to turn into 5 times 9 times 10 to the 6th power times 10 to the 3rd power. So now we're actually going to multiply these two together. So 5 times 9 equals 45. And then using what we learned in 6-2, we are going to multiply this times 10, and then we're adding the exponents together. 6 plus 3 equals 9. So now we can take 45 and put it into scientific notation. So we want to turn this into 4.5 times 10 to the 1st power, and then we're going to multiply that times 10 to the 9th power. So now we can combine these like terms. So we end up with 4.5 times 10 to the 10th power. And that's our answer. It's a little more complicated. See if you can figure these two out on your own. Come back to me when you're done, and we'll work them out together if you're not sure. Okay, so we should have got 8 times 10 to the 9th power and 6 times 10 to the 13th power. So I just want to revisit up here how we had to do that second step where we turned the 45 into the 4.5 and then added in the term 10 to the 1st power. So as long as it's just the ones place, you do not have to do that. But 45 has a ones and a tens place, and that's why we put it into the 4.5 scientific notation. You just want one number in the ones place. Everything else should be a decimal point after that. So that's going to be the key to knowing if you need to then change it into scientific notation, that particular number. And then if so, you then have to combine it with the one that you've already multiplied. Hope that makes it a little more clear. So, application. A light year is the distance that light travels in one Earth year, is about 5.9 times 10 to the 12th miles. A mile is 5.28 times 10 to the 3rd feet. How many feet are in a light year? So all we're doing here is multiplying these two numbers together. So we have 5.9 times 10 to the 12th power times 5.28 times 10 to the 3rd power. So let's switch it up into similar terms. 5.9 times 5.28 and 10 to the 12th times 10 to the 3rd. Oops. And when we combine those together, we have 5.9 times 5.28 equals 331.152 times 10, and then 12 plus 3 is 15 to the 15th power. So this is where we want this to be in the ones place. So we're going to move the decimal point over one place. So then we have 3.1152 times 10 to the first power. That's how we moved that over. And then we're going to multiply that times 10 to the 15th power. So our answer is going to be 3.12, we're rounding now, times 10, and then 1 plus 15 to the 16th power. You go ahead and try this next one on your own. The speed of light is about 3.0 times 10 to the 5th kilometers per second. Use the formula distance equals rate times time to find the distance light travels in an hour, which is 3.6 times 10 to the 3rd seconds. So you are just multiplying this times this. Press pause, figure it out, come back to me when you're done. Okay, so you should have got 1.08 times 10 to the 9th power. Right, I had to move that decimal point. Therefore, I added in this extra 10. 10 to the first power, 1 plus 8 equals 9. Okay, so let's look at these together. So if we are going to multiply these, right? So here we know 3 times 6 equals 18. But this is 1.8, which means 10 was taken out. So 110, so if we have 110 plus this 4 plus this 12. 12 plus 4 is 16 plus 1 is going to equal 17. For number 2, we have 7 times 1.8, and so that equals 12.6. But if we look here, this is a 7, this is an 8, so that means they pulled the 10 out of here to make this equal 1.26 times 10, and which was added to that number to get 10 to the 8th. So this is our missing number. Number 3, we have 1.9 times 6.4, which equals 12.16. And you can see this one has it as 1.216. Therefore, they have an extra 10 that they multiplied. So if we have a 10 to the first times 10 to the 5th times 10 to the 3rd, that's going to equal 10 to the 9th. Number 4, they multiplied 5 times 3.2 equals 16, which means they had to add in a 10 to make this 1.6. So now we have 110 plus 10 to the 7th is going to equal 10 to the 8th. So the speed of light is about 3.0 times 10 to the 5th. A kilometer is about 6.621 miles. So if we want to write this, we would go 6.21 times 3.00 times 10 to the 5th. So if we go 6.21 times 3, That's going to equal 18.63. We need to move the decimal, so that's going to equal 1.863 times 10 to the first power, and then we can't forget about this, times 10 to the fifth power. So it's going to equal 1.863 times 10 to the sixth power. Okay, so today, boys and girls, your homework is page 190, number 7 through 15 odd. Happy homeworking!